Yes, dear student, here in this video there are two questions again. Question 1, a body of mass, I am speaking, please listen me carefully what I say, because you may feel some difficulty in reading the writing. A body of mass 0.5 kg, mass 0.5 kg is moving in straight line with speed v a equal to a into x to the power 3 by 2, where a has a unit 5 per है ना. Calculate the work done by the net force in displacing x equal to 0 to x equal to 2 meter. This is a question from NCERT book. And this question in fact is based simply on the Work-Neri theorem. There may be little sound because it is very hot, so I have to run the fan as well as AC, which are being acceptable here of sound. Please adjust with me, help me listening. So question 1 is that a body of mass 0.5 kg is moving in a straight line with speed v equal to a into x power 3 by 2. To calculate the work done by net force, which is making the body move with this speed and displacing it from 0 to 2 meter. So in fact, here solution is like this, simple. V equal to a 5 into x power 3 by 2. Sorry, 3 by 2. Velocity at 0, displacement at x equal to 0. Equal to 0, or velocity at 2 meter, 5 into 2 to the power 2 by 3, 3 by 2. Remember here, x to the power 3 by 2 means, इससे बच्चे students are very much afraid of such thing. It is x into x to the power half, simple, or x to the power root, under root. So you can write it as 5 into 2 into root 2. यानी 10 root 2 meter per second is the velocity. So change in kinetic energy. Initial k I बराबर 0 है, k final half mv square. Why it is 0? Because v is equal to 0. Half into mass 0.5 into this is square 10 root 2 whole square. How much it will be? 1 by 2 into 0.5 into 100 into 2. This 2 cancel. It is simply 50 joule. So how much the change energy? Kf minus Ki. 50 minus 0. Hence work done is equal to Ki minus Kf, Kf minus Ki. Kf means fine energy initial, equal to 50 joule. A simple question, but in my teaching experience I found the question is very difficult for students because they are afraid of such things. These things you will get clear only when you will try the questions from NCERT book and some other books also. Now question number 2, which is written here, a lengthy question. It is based on perfectly inelastic collision. Perfectly inelastic collision. What is that? A bullet of mass 0.012 kg and horizontal speed of 70 meter per second strikes a blow of mass 0.4 kg and instantly comes to rest with respect to blow. The blow is suspended by a thread, by a string like this. I am explaining the question again. Actually, to teach topic is simple here. its mass capital M लिखा हुआ है 0.4 kg. A bullet here of mass 0.012 kg strikes this, comes to rest instantly. So when it comes to rest, get embedded into it, means clear cut, the collision is perfectly inelastic or plastic collision. I have given in the notes while teaching inelastic collision, when two bodies after collision get embedded into each other, then collision goes perfectly inelastic. So here asked how high it will rise. It may go like this somewhere. So ये center mass, how high it will rise and how much the heat produced. G 9.8 meter per second square. For more clarity, you can read this question in your NCERT book. Now I come to the solution. Now question is clear. Bullet of mass 0.12 kg and horizontal speed 70 meter per second strikes a block of wood. It may be a sandbag also. I think in NCERT book it is in sandbag of mass 0.4 kg and comes to rest instantly. Then how high it will rise, the block will rise, and how much the heat produced. So it is case of exactly case of perfectly inelastic collision. In perfectly inelastic collision, I told you that momentum remains conserved. And I told you why momentum always conserved in collision, because whatever be the collision, momentum always conserved. Why? Because no external force acts. And when no external force acts, momentum conserved. So let this mass small m. So final momentum m plus m into v is equal to v the speed after collision is equal to mu. U is this speed, sorry. You can add this as u. So here v is equal to mu upon m plus capital M. So the block and the bullet together will move this velocity after collision. Now when it rises from this position to this, now it is free from any force of friction. So kinetic energy converted into potential energy. Kinetic energy into converted into potential energy. So potential energy m plus m into gh is equal to half m plus m into v square. V this. So it is half m plus capital M into v square. M square u square upon m plus m whole square. So this m cancel. So h will be there only. M square u square upon 2g into m plus m. Square. You put the value, you will get the answer. And here answer comes out to be this height risen. This come out to be equal to 0.212 meter. You can solve it easily. Now, how much the heat produced? So here this velocity from equation 1, velocity after collision क्या होगा? 0.012 into 70 upon 0.412. If you solve it, you will get it as how much? 1 into 412 into 70. है भाई 4 3 जा 4 1 जा 0 3 जा 210 upon 103. If you divide it 210 divided by so 2 जा 4.00. So nearly you can write it will come out to 2 only, nearly. Therefore, the kinetic energy after collision and kinetic before collision. Initial kinetic energy किसकी है? Bullet half mv square sorry. 1/2 into 0.012 into 70 square 4900 और K फाइनल 1/2 टोटल मास होगा 0.412 into 2 square. Cancel. Multiply this. Solve it. You will get answer is here. Nearly 28.5 joule. And by loss of energy. Heat produced will be how much? This minus initial energy. This minus this करते हैं. ठीक है भाई. तो loss of the heat produced. Here heat produced is equal to heat produced Ki minus Kf. Yani how much is this? 0.006 into 4900 minus it will be 428. This is 0069 54 5 6 4 25 29 decimal after 3 minus 0.824. So nearly 14 minus 8 6. So this answer has come out to be equal to 28.5 joule. And this loss of energy is equal to heat produced. So this is the question here which I solved for you. Now there is simple question in my brain which I find students are not able to solve. Why question simple? Dear student, my video become longer. Actually, my aim is to tell you more information in one video. Also, it takes time for me. एक सिंपल क्वेश्चन मेरे दिमाग में है यहाँ पर. क्या है भाई वो? Here on this table, this is a frictionless table. Two blocks of mass MA or MB are held together and spring compressed. The spring is compressed here. Now when we release the masses, then he asks you find the ratio of kinetic energy. Find the ratio of. You are not given here about spring constant, nothing else. Simply you are given the mass A and B connected by spring, which is compressed in compressed position. Now if it is released, then we move to find the ratio of kinetic energy. Yani Ka upon Kb. K means kinetic energy of A, kinetic energy of B का ratio निकालना है. How much that? ये कितना होगा? अब आप मेरे पास नहीं हैं, नहीं तो मैं ट्राई करता कि आप कोशिश करें. देखो, इनिशियली द टू masses are at rest, and after releasing they will move initially two masses are at rest. So momentum of system before masses are released zero. Now let after releasing the spring there will be V1 V2. So momentum of system after the bodies after the spring release after release will be MAVA plus MBVB, where V and VB are the velocities. Since no external force is there, so momentum conserved. Since momentum is conserved, momentum is conserved here. So MA into VA plus MB into VB equal to 0, or MA into VA equal to minus MB into VB, or VA upon VB equal to minus MB upon MA. Minus sign is there, will be moving in opposite direction. Clear? So now, what is Ka? Kinetic energy of A equal to half MAVA square, and that of B half MBVB square, and therefore Ka upon Kb MB MA upon MB into VA square upon VB means minus MB upon MA square. So you will get minus plus हो जाएगा और you will get MB upon MA. So you have to apply the facts you have learned. Don't think that these are not questions for you. Basically, the questions given in book, numericals given in book, are meant for you. You are supposed to do them yourself. But our situation becomes difficult when we are not able to solve. Our brain stops working. Please keep on thinking and keep on revising the tricks which we apply to solve here. Thank you. मिलते हैं फिर.